Hello, welcome to Anadot and King's webinar, The Cost of Downtime and Minimizing Downtime. Thank you everyone for joining us. We're going to give people about 30 more seconds to join in, but thank you for taking the time. We're very excited for today's webinar. And just so you know, if you can't stay till the end or if you need to pop out for a second, at the end of the webinar, we'll be going through a step-by-step process for the cost of downtime and how to calculate it yourself with a free tool that Anadot offers online. So you'll definitely want to stay till the end for that. And we'll also have a live Q&A with both all our wonderful participants at King. Joining us today, first off, I'll talk about our moderator, which is Amit Levy. He is VP Product and Marketing at Anadot, and he brings a lot of experience in planning, developing, and shipping large-scale data and analytics products to a lot of mobile and web companies in the past. He's a product and data expert, and he has a lot of experience explaining really complex requirements in a really simple and straightforward way. So he's definitely the type of person you'd want moderating this type of webinar. And he's previously worked at Yoki Music and Hula Data. Also joining us from King, we have Lucas Korbolevsky, who's head of incident management there. Lucas has been with King for nearly 6 years. He's currently their senior BI developer at the incident management team. His favorite task has been the deployment of the world's first-class data tools, most recently, the implementation of Anadot. Thank you, Lucas. And in the past, Lucas has held various analytical roles within lastminute.com, and he's had prior experience as an incident and problem manager at Capgemini Group. Personally, his favorite things are good design and spending time hiking in the mountains with his family. So there's a little something personal about Lucas. Carolina Martinez is also joining us. She's senior data engineer at King. Carolina has more than 10 years of experience in data processing, and she spent the last 4 years focusing on big data at King. So she's currently part of the incident management team there and has a background in engineering, and she's previously worked as a business intelligence developer at Coolblue, which is an e-commerce leader in the Netherlands and Belgium. She's also spent many years in project management in the telco industry. And also joining us is Jacob Berglund, incident manager at King. He's got a history also in business intelligence in retail, marketing, manufacturing, healthcare, finance, HR, legal. He runs the gamut apparently. And Jacob has a passion for extracting insights from complex data sets. He's been at King for nearly 6 years. And he's been working with the incident management team to create a data-driven follow-up to incidents in the service organization, where he currently serves as senior incident manager. And with that, I'm going to pass it over to our moderator for the event, Amit Levy, VP Product and Marketing here at Anadot.
Thank you, Debbie. Why do we even speak? Why do we even talk about the cost of downtime? So actually, businesses can't afford to find incident late. According to plenty of research, we see that according to Washington Post, we see that around 31 hours that are lost every week due to incidents, and every incident costs around $300,000. That's according to Gartner, and that really has a major effect on revenues. And if you look at another research by DEG, we see that the cost of downtime eventually is millions of dollars every year, and it results in IT labor, in brand recognition, and also in direct loss of revenues. And actually, the trend is that we see more and more outages reported year after year. Maybe it's due to the fact that this is more publicly transparent, or maybe since operations are becoming more complex, there are more issues to be monitored. And I just want to share with you one example that we'll see in a more visible way. How would the downtime be associated with direct cost? This is an example of a customer that monitors number of purchases basically on an hourly basis. And then at one time, at a specific point in time, number of purchases really decreased. And this customer was not working with Anadot at the moment when that happened, and it took that customer over 38 hours to identify that there's a problem. And this resulted in over $200,000 loss in revenues. Well, if he had used Anodot, he would be able to detect this incident immediately. Why is it even important to understand the cost? And basically, we see two main reasons. The first reason to understand the cost is basically to be able to have management buy-in and to share the effect of those incidents on the company and see how can we really affect the bottom line of the company. And the other very good reason is operational excellence. We all love to be professionals at what we do. We want to have the best service possible. And if we use the best tools out there, we're able to serve our customers in the best way possible. And that's something we all aim to. And with that, I want to pass it over to our friends at King, and they will share in more details specific examples and how they reduce and actually even prevent incident costs.
So for those of you who don't know who we are a games developer with more than 200 titles developed, and they are played by over 258 million people worldwide each month. This is a selection of some of the most popular games that you may have heard of or even played yourself at some point. But now, the incident management team at King is a team of mixed profiles. We have data engineers who are responsible for general tooling, supporting us, and also ad hoc analysis. And two of them are here with us today, Karina and Lucas, to present parts of what they work with on a regular basis. We also have data scientists for specialized tooling and deeper ad hoc analysis, and also a bridge to the company to try to explain. Then there are the incident managers responsible for handling the day-to-day operational process. And finally, a service operation director managing the high-level operations and the team. As you might understand from this, we have a wide variety of heavily data-driven capabilities, which we utilize when we handle our incidents at King. We, in the incident management team, are driven by 6 core principles. The first 3 are aimed at detecting, identifying, resolving, and effectively communicating around the issue. And the final 3 is about collecting the data, sharing it, analyzing it, and making sure the same issue doesn't happen again. And this last mission is by far the most important, but also the hardest of what we do. In order to facilitate our missions, each incident follows a fairly straightforward process, where we are notorious in logging as much contextual information as possible to help us to create a platform that supports detailed analysis, helping to prioritize efforts where future improvements provide the most value. I will give you a moment to reflect on this process, as it's in principle quite similar to most incident managers' processes out there. The main difference in what we do compared to many other organizations is how wide our responsibility stretches in both directions, both in the detection early on and also in the problem and change management later on. Ultimately, though, this is not just a process. It's a cycle where any improvements we do on detections gives more time to focus on driving the overall improvements, which in turn reduces the number of alerts we trigger in the first place. So while adding new areas to our scope of coverage and fine-tuning the process to minimize incident lifetime, we identified that the biggest single contributor to incident impact was slow incident detection. So we decided to do something about it. So a big difference between us and a traditional incident management team is that our team was created with the business perspective as our first priority. So that means taking care of game client issues and operational issues from the business perspective. But over time, we also expanded to cover traditional areas such as supporting technology and infrastructure. So to give you some type of context of what type of issues we cover, it's basically what's on the screen. Some of these are simple to detect. It's basically a line on a chart going down. Others are more complex in nature with a multitude of factors going into it, contributing to the total. And looking at any single chart might not even indicate something is wrong. This has a major impact in our possibility to quickly detect and alert on incidents, which I will show in the coming slides. Let's first look at time to detect for incidents that are simple in nature. We measure time to detect as the time it takes from the start of an incident until it's detected by monitoring either systems or people, whichever is faster. And the simple nature of an incident is, like I said, when it's clearly visible, looking at any indicator that simply just drops. It's the type of indicator that you see in retrospect and think, why didn't we catch this one faster? In this graph, you can see 2017 as a reference point at a time before we were using Anadot. Most of our company alerting revolved around daily alerting, and late December that year, we adopted a proof of concept for Anadot, which we then rolled out company-wide in 2018. More or less out of the box, we had automated coverage for the most important metrics spanning all hours of the week. And the effects did not wait. And as you can see, the time to detect improved by an astonishing 71% in the first year of usage. Moving on to 2019, we took the opportunity to heavily tweak which alerts were important and which were just contextual noise. So this, in combination with an advanced analytical follow-up on the quality of alerting, which Lucas will talk more about in later on, enabled us to further reduce the time to detect by more than 75%. So we are now at the level of where fast incident detection for simple incidents is no longer the main contributor to impact. Let's look at the time to detect for incidents that we consider complex in nature. And by complex, again, we mean that the incident is not clearly visible on any single indicator. There's no obvious showing of any major drop. It could be a combination of factors or a drop that's small enough to not be picked up by conventional alerting on its own. Again, as you can see, in 2017 is the reference point before the implementation. In 2018, there's clear improvement just because of the visibility that Anadot brings across our network, allowing to correlate different metrics for a higher significance of the alerts. And the time to detect improved a good 10% this first year. Looking at 2019, we still had a lot to learn. As with all anomaly detection systems, Anadot also generates its fair share of false positives, because there is simply no single formula to detect 100% of incidents without also generating some noise. Through constant tuning of our alerts and focus on which metrics were the key drivers in the correlated events, we have been able to drive the time to detect down by an additional 24% this year. We still see room for future improvements, but we also have to ask ourselves, considering the best time to detect for any incident is 0, is that a realistic mission? I will hand over to Carolina to talk a bit of how we have improved towards that goal.
Thank you, Jacob. As Jacob was explaining, the time to detect is the time from the beginning of the incident until we are able to detect that. And earlier at the beginning of this year, we were wondering, is it possible to reduce this time to 0? What could we monitor to know something incidental is going to happen? The answer was, let's try to monitor our backend metrics, the metrics that come from our backend servers. We made a POC, we loaded this data back in time into Anadot, and then we analyzed what Anodot which anomalies we could see there, and if they were a reflection of past outages. We loaded into the system RPC calls, garbage collection, stop times, and Jetty queues information, and we saw really interesting things. I'm gonna go through it on the next slide. And so we just put this in production, and now Anodot is able to alert us before incidents actually happened. I'll show you also a couple of examples on that. Going back to the POC, earlier this year we had a game cluster outage where the cluster just went down. This had minimal impact on players because the clients were still working and people could still play, but this forced us to have a quick reaction and get to work on this incident. What we saw backloading data into Anodot is that there was signs of anomaly 10 hours before the actual outage, which was telling us that if we load systematically these metrics into the system, we are able to detect that things are not quite right way sooner than the incident occurs. We then proceeded to load all these metrics into Anodot, plus some information about semaphore acquisition times. And the result was that we could prevent some incidents from happening. A couple of examples is this one happened around April, where nothing really happened. We just saw a spike on semaphore queues for some of the games, and the game team just jumped into it, and they discovered that the earliest release contains a bug that could potentially cause some crashes. So they just, same business day rolled out a fix, and nothing ever happened. Another good example of how Anodot helped us prevent incidents was in the rollout of a live up feature. We started rolling this feature to some of the players, and we saw garbage collection stop times and execution counts going up. Immediately the team jumped into it and saw that there was a misconfiguration, so we could just hotfix these on time, and then by the time the feature was completely rolled out, everything was working perfectly. This is a couple of examples of how Anodot can help us prevent and early detect incidents. And next, Lucas is gonna just go through a little bit more detail on how we operate with Anodot, just to get to this point.
Okay. Hello, everyone. Jakob and Carolina were talking about how we were looking at incidents and detecting them, and also how to minimizing the time to detect them to basically minimize the effect of those incidents on our users, and then going this extra step where we are able to prevent incidents from happening and from affecting the user experience. So I wanted to talk a little bit more about how this whole path looked like. So when the incident management team was established, the main focus was the business KPIs, and this is what we were first monitoring, and this is where the team's focus was at. And however, at this stage, we already saw that the user experience was being impacted, and this was already in the area of the incident. So then we moved to monitoring the IT infrastructure, and because we realized that by looking at the health of the servers and all the infrastructure components, we can actually prevent incidents from happening, from having the impact on user experience. So we expanded the coverage into that area. When this was relatively under control, we realized that we have also different components that are not our core game product, but they do support the game. So we have teams here that develop different supporting tech, and we expanded our monitoring coverage over those. Additionally, when there are new business initiatives at King, we also expand our incident management service on those, and we start monitoring the most important KPIs there. So we have pretty broad view. I mean, in more traditional ITI-based incident management, it's usually a team that looks at certain particular area. Most often that's a piece of IT infrastructure. While in here, we actually started more from the business side, then moved more into the IT, and therefore we're covering a pretty wide aspect of different activities within the company. But also, this gives quite a lot of data and different monitoring KPIs to look at. So, for instance, in this diagram, you can see that how much data in terms of time series each of these area produces and what we are covering. So, like in business KPIs, for instance, we look at 5,000 different time series, where we look at the most important KPIs, but those are split per platform, per country, and per different builds. In the IT infrastructure, we look at different hosts and the most important metrics for that. This all together forms additional 14,000 time series. Then we have supporting tech and new businesses. So altogether, that's quite a lot of data. And this is already a data that we kind of establish as the important ones to look at. So I wanted to show you what was the process of defining this this focus. So at King, since we operate on a very massive scale and worldwide, there's a lot of data going through our infrastructure. So there is a funnel which you can see on the screen, which starts from all the events that are generated by our clients, and we have around 80 billion events of that type every day. So all of these events are being streamed to either Kafka, or they are also being copied to warehouses. These are all the events that the client sent over, but not all of them are equally important to us in terms of monitoring and support. So there is a concept developed at King, which is an abstraction layer that groups the most important events together. We call it the semantic classes. So these are events that are flagged to be the most important. So in here, we already narrowed down the focus into the most important events by using this concept. So let's say these are the business relevant events. From there, we look at those events, and thanks to a internally in-house built a piece of infrastructure that we call RBM, which works on Kafka and real-time streams, we can grasp those business relevant events and with RBA apply some logic to them. So we can aggregate them, we can define different conditions, and as a result, we can produce a set of very meaningful data sets or data streams that are already aggregated to some extent and are really meaningful to us. Okay, so it's not just a bunch of numbers. We know exactly what it means. So this is the part that we then send over to Anodot for anomaly detection, and this is where the machine learning kicks in. And Anodot, by looking at all of these streams, is producing around 40-50 anomalies a day, and these are the anomalies in the system. But there is one more missing step, and when we tried different other applications for anomaly detection, they were usually missing this step, where you look at all the anomalies that you have, but also apply a business logic to those, a business knowledge of differentiating between what an anomaly is and what an incident is. So in here, we can define this business acumen and then turn those anomalies into meaningful alerts, which goes down to, on average, 3 alerts a day. So this is the funnel of how we look from greater perspective into the focus that we can control. Apart from the fact that we were able to narrow it down to the essential parts, we also felt the need to analyze the efficiency of the system as it is. So our incident managers, when they are working with incidents, all the information related with incidents is logged into Jira. We then fetch this information and we compare this with alerts in order to understand whether the incidents were captured or not. And this way, we analyze the efficiency and the coverage of our monitoring system. So for instance, on the snapshot from September, you can see that in most categories, we picked the incidents that were happening, apart from one. And this is where we know that we need to expand our coverage or learn new things. In most common cases, the reasons for the missed ones are either we are not covering a certain area yet, or we started covering, but we still need to learn what would be the best approach and sensitivity levels for certain types of anomalies. We also look from a different perspective. So in there, you were looking at the incidents and whether they were captured or not. But as Jakob mentioned previously, each anomaly system, including analog, is generating a certain number of false positives. So we also analyze this. So we have built a kind of analytic system on top of Anodot, where we fetch data from different Anodot APIs, put them together, and then we look at the rate of all the alerts on a certain period. We then also look at which game or which part of the infrastructure is generating the increased false positive rates. So based on this, we can tweak our alerting system, or this is also kind of additional meta information for us that certain areas of the infrastructure perhaps are not as efficient as they should be because they are generating for some reason a higher alert rate. So this gives us additional feedback on how our monitoring works. On top of that, we also look at the feedback sent by the alert recipients, and we analyze this. So every time we receive alerts or the users are receiving alerts, they are encouraged to go through the alert console to check the alerts and provide the feedback whether the alert was a good catch or not. And this is not necessarily one-to-one with alert, because what we learned with incidents, what we learned is that not every alert turns into an incident, but still this alert is valuable because it's informative for us. So perhaps not on every of those we need to necessarily action, but it still gives us additional context of how certain parts of our monitoring works. So then we analyze also the feedback of the users and set our own goals of how the detection system should work. So we treat this as a KPI for further improvement of the alerting. And eventually, the ultimate goal of our support is basically to keep the users happy. So I think this is all what I wanted to say about how we looked at the anomaly detection and the incidents. And thank you for this part. I'm going to hand over to Amit. So let me just stop sharing, and Amit, if you could take it over.
Thank you, Lucas and Jacob and Corley. That's actually amazing. I've been listening very carefully, and you also mentioned I think two facts that I find the most interesting. One is that in some cases you actually really are able to prevent events. Really able to prevent events using the early detection, which is amazing. And then also the fact that eventually you stream into your systems more than 80 billion events every day, and that only translates to 3 alerts. I'm sure that has an enormous effect on how your team operates. Can you share a bit on how does this affect the way your team operates?
I mean, it basically allows the team to operate. Otherwise, we would be just stormed with the alerts. I think what's essential in there is that we have developed in-house this RBA system, which is really awesome and allows us basically to get or like to understand our real-time data. You know, when you look at the raw events, it's just overwhelming how much of this is there. So without this part of the infrastructure, we will be totally flooded. Especially now when the game operations are more and more into running live operations. So like, you know, there was the paradigm before where most of the game developers were just releasing new levels and then shipping them to customers. This has already changed. And if we didn't have this part of the infrastructure, we just wouldn't have visibility on our daily operations. So this is like the crucial element of the whole puzzle. And then Anodot ties very, very neatly to that. What we do with the alerts is that obviously the incident managers, they receive those alerts to act upon. Each alert has a screenshot of how the data looks like at the moment, so it's immediately visible whether this is something grave or not. We also have annotations on releases so that we can easily identify whether this is an effect of the latest client build or not. So yeah, all of these elements that help us to operate essentially.
Why did you decide to use Anodot or to choose Anodot, and on top of that, instead of building it yourself? Like, I guess instead of building anomaly detection yourself, why did you choose Anodot? What was like the
okay, so we did try it internally, okay? Before the Anodot and before the whole RBA part that I was saying just a moment ago, there were a few initiatives in building anomaly detection system in the company. And these initiatives were not successful because there was a difficult access to clean real-time streaming data. Then there was the RBA. And more or less in parallel to this, we first adopted a tool that was used by the IT support for managing networks and servers, hoping that this would give us a good anomaly detection system. However, it was more designed for IT infrastructure, for logs, for different types of data that is not necessarily business related, okay? And then at the same time, there was a very simple initiative, a hackathon within the company, and some of the people created a very simple system for capturing the real-time streams coming from RBA and putting some kind of detection on top of that. Okay,
nice, you had an anomaly detection hackathon?
Yeah.
Or that was just one of the things they'd made?
No, it was just a hack day, and people thought that this would be a really cool project. So when we actually started reviewing applications to use, we had several options, and we looked at each of those, and we created a scorecard and scored every feature that we thought is important for us from 0 to 5. Then when we summarized everything, we realized that Anodot has the advantage of other tools. We also made a survey within the team to see who likes which product, and therefore we chose Anodot eventually. The main difference was that each of these tools had some kind of anomaly detection mechanisms. Some of them were basics, some of them were more advanced. The more advanced the mechanism was, the less false positive it was producing. So this was like the first level. And then the second level is what I mentioned before, that none of these systems had additional layer which will allow you as a business user to take all the anomalies that the system produces and apply what you consider to be an incident. Okay, so this was the main sell for us, and it was also showing the biggest maturity of the product. Okay, and also the difference was that some other tools that on the market, they were much more designed for IT people, while this one is much more business oriented. And then essentially here in the team, we're different types of business analysts. So this was the closest fit to our needs eventually.
Question.
Okay.
Great. That was a really thorough explanation, and appreciate it. Good answer.
Right.
That was a good answer for whoever asked that. And let's see, next one we have. Does that mean? Oh no, here's a good one. What other systems for anomaly detection do you use besides Anodot?
So within the company, we also have a whole plethora of Grafana dashboards. So this is more on the backend side of things, and the backend developers, they use Grafana as their main dashboarding system. And within the Grafana, you can also implement simple rules for detection. They very often backend developers who manage servers, they also create a kind of a system of flags when certain metrics meet a threshold, then the flag is raised, and then therefore there is an alert raised on the Grafana side. On the more like business performance side of view, we also use Looker as our main business intelligence tool. So in there, we also set up a certain type of anomaly detection. However, this is more for looking at different trends. Okay, so in there, we look for longer time perspectives. Then we compare this more against the market, against financial forecasts, and so on. So Anodot is much more for like operational day-to-day usage. While these other tools, it complemented because of looking at different perspective or time spans and so on.
That's actually, it's interesting you answered that, because one of my next questions was someone wrote in, how is Anodot different from Looker's alerts? So that was a good that you covered that topic. One of the last questions before we move on to the next part, which is calculating the cost of downtime, is what are your time to detection targets for 2020, and how low you think you can go?
So unfortunately, we cannot share any specific numbers, but as you have seen, we have improved significantly year over year just by having the tech in place and the visibility. And now, as we are having this meta information on top of the alerts, we can define the quality of each, where we want to focus next. The issue here is more that since we're continuously expanding our coverage, we have to make a business decision on whether it's worth improving the time to detect or expanding the area of coverage without hiring more people, obviously. So if we get to focus entirely on time to detect, which is an ideal scenario, then I'm positive that we can reduce our time to detect by an additional 20% at least, just by using this information we have. And I would say that for simple ones, perhaps not, because we reached near to the limit, but for the complexity of the nature, there we have a lot of ideas and things we can improve.
Great, guys. Thank you so much. That was super informative. I appreciate that. We're going to move on with the back and send it back to Amit, who's going to start now talking about the cost, calculating the cost of downtime and how people can try to do that themselves. So handing it back over to you, Amit.
Thank you. So during this last session, last part of this webinar, I want to share with you a little more about methodologies that we can suggest in order to calculate the cost of downtime and of incidents. Basically, let's start with what do we do here at Anadol. So as I hope you all know, we use AI to constantly monitor and correlate business performance. And there's a big emphasis on business, as the team at King mentioned, in order to provide real-time alerts and even forecasts that eventually reduce the time to detection and resolution to dramatically impact bottom line. And we do it at enormous scales. We take over 4 billion decisions every day with zero human touch. And those decisions are basically looking at every data point that we collect and then decide whether or not this data point is anomalous or is it within the acceptable values. And now I want to talk with you a little more about the cost of downtime. So we actually, for this webinar, we've built an annual calculator which will enable any one of you to answer a few questions and get a very comprehensive report about the cost of downtime within your organization. So I want to briefly go over this report with you, and of course, after the webinar, we will share it via email with all of the webinar participants. Okay, so basically, it's a simple web page, and I will now go through a short few questions, and I will answer them with a fictitious company. And let's call it webinar time. And once I can select an industry. It can be a company with the gaming industry, such as our friends at King, but also in other industries as well. Let's choose the e-commerce industry as an industry. And then, of course, where am I from? And then what is the relevant department? Let's go with people that are around data, such as our friends at King. And then I go and answer a few questions about the current solution I have in place. So first of all, some information about my company revenues. Let's assume that my webinar companies produces around $30 million in revenues every year, and I measure a number of metrics in my system generally, and also a number of KPIs that I monitor effectively every day. Basically, this is the numbers I see in dashboards. Of course, one of the challenges is that dashboards are limited with the number of KPIs that I can view. So let's say I currently look at around 75 KPIs using my dashboards. And then I'd answer how much time does it usually take for me today to detect incidents and resolve them. The next section here talks about the current solution I have in place. Let's assume I've developed something in-house, like our friends at King in the past. And this something that I've developed in-house is mostly based on static thresholds. And it collects data from 2 or 3 different data sources. Now there's another line of questions that is specifically focused on the challenges I have. And how important is it to me for me not to miss an incident, and how would I describe my current ability to identify incidents? So and of course everybody can answer that to what makes best sense for you. after I go, I'll spare some of the time, but after I go and answer this entire questionnaire and answer questions around granularity and effort and additional questions, I can actually get our algorithm calculates an estimate cost of downtime for my company based on the answers I've answered. And then what is the projected savings I can have if I choose to use a modern tool. And the last thing is that you can actually download a full, a very comprehensive report that details the kind of, it doesn't matter if you choose to do it with Anodot or you choose to do it in another way. This report details the kind of solution that you have to build or onboard in order to maximize the revenue saving. So as I said, I'll be happy to share this with all of you after the webinar. And that's for that. So I'll try and wrap up. Basically, first of all, Lucas and Jacob, Carolina, again, thank you very much for taking the time and sharing some of your experience. I got to tell you on a personal note, your work, the work that you do and the way that you utilize Anodot is amazing. And I'm sure that that you see the value in that, but from our side, it's just admirable to see the professionalism and the way that you utilize the technology that we've built. And the main things I want people to take from this webinar and from the lessons that you shared is, first of all, that we can use state-of-the-art technology in order to improve everything we do. Specifically, in our field, if we use the best technology, we can reduce and even prevent revenue loss in a significant manner. And in gaming industry and in other industries, as user experience is so crucial, other than revenues, it really translates to better user experience and to better experience to our audience, which is this is the topmost goal for any company.